Additive manufacturing. Is it the future? First of all, it is important understanding the concept of additive manufacturing. Accordingly, with the American Society for Testing and Materials, additive manufacturing is the industrial term which describes all the technologies used to build 3D printing objects, by adding layer upon layer of material until reaching the desired shape. However, why is additive manufacturing important? The reason is related to the fact that it is obligatory adopting innovative technologies capable of reverse many of the problems caused by the manufacturing industries and processes. More than ever, it is essential implementing environmentally friendly, efficient and multifunctional technologies. Due to this new scenario, industry and researchers have developed new additive manufacturing technologies to substitute the conventional processes which, inevitably, have led to the rising of ambitious projects. One example of the last statement is the pioneering initiative called Hiroman, which is integrated into the Industry 4.0. The aim of this initiative is creating a hybrid working cell that combines additive, subtractive and transformative processes, fully executed by robot manipulators, in order to allow the manufacture of any kind of objects. Therefore, this new concept of production is expected to produce a significant impact on industrial variables through an estimated decrease of 20% in the production time, 25% in the production costs, and 50% in the resources costs. In the last years, this initiative has inspired a lot of researches, such as the last one from the University of Coimbra, whose objective was the development of an additive manufacturing simulation controlled by a system control application. However, how is this done? Well, the answer is simple. The development of the additive manufacturing simulation was done by merging the industrial robot software, RoboDK, with the open source software Slicer, while on the other hand, the system control application was fully developed in Python. As previously mentioned, RoboDK is an industrial robot software that allows offline and online robot programming. The robot offline programming was an essential feature since it allowed the creation of a virtual simulation, which is responsible to emulate the real working cell, as well as all the additive manufacturing tasks. In terms of design, the working cell was projected to be simple, flexible and efficient, being only composed by a robot manipulator, an extruder and a bedplate. However, to perform an additive manufacturing simulation, it was necessary generating robot programs capable of executing all the additive tasks. By merging RoboDK and Slicer, it was possible generating a robot program that contains all the necessary information to generate a virtual simulation. In addition, it is important to refer that all the programs generated can be later executed in a real robot station and followed through a virtual simulation. However, the simulation would not have any practical interest if it was impossible interacting with itself. This is justified by the following arguments. One of the main goals of the Hiroman initiative is creating a standard working cell that can be used to produce any kind of objects, under some size limits. This means that it is necessary interacting with the RoboDK's working station to generate the printing program, accordingly with the new object to be produced. Another important point is the fact that additive manufacturers' technologies do not use to have static parameters since they need to be adjusted under simulation, whereby a complete monitoring of all parameters is also essential. Finally, for security reasons, the additive manufacturing tasks must be launched as part of the RoboDK environment in order to prevent errors. Therefore, the interaction with the simulation is ensured by using a system control application. This system is an app, fully developed in Python, that allows a user to control and monitor the entire simulation. As mentioned before, Hiroman is an industrial initiative, so the system control application needed to be built with special care in order to make it usable by any user. This was done by designing a user-friendly interface that performs all the controls by simple commands, such as clicking a button or dragging a bar. As extra feature, the system control application has the slicer fully embedded to make it able to generate G-code automatically by simple commands. This feature also gives to the user important information about all the parameters used to slice the part, as well as part-specific information. The final result was a system control application that is able to control and monitor an additive manufacturing simulation, as can be seen. To finish this presentation, it is important keeping in mind that this is not a final product. However, this is definitely a huge step to progress the Roman initiative. Additive manufacturing technologies will certainly be the future, so if you are interested in this kind of manufacturing, please stay in touch. Share this video and give your opinion or suggestion to keep growing this project. For more information about the Roman initiative, please visit the comment section below. Thank you for watching this video, and I hope to see you as soon as possible.